Alright, today is the day we start to learn some of those tricks to finding derivatives. So we're going to start by looking at some of those tricks, the shortcuts, rather than using definition of derivative. So what I have here is this says, when you're going to find the derivative of a constant, say 5, the derivative of a constant is 0. I want to explain this just a little bit, why that is the case. Really what we would be doing is in an equation like this, y equals 5, we could say the derivative, okay, which this is the same symbol, is equal to 0. Why is that the case? Well, think about what a graph of y equals 5 looks like. Y equals 5 is a horizontal line. Well, really what you're asking yourself when you're finding the derivative is what is the slope of that line? That slope of that horizontal line is 0, so it makes sense. Let's look at the second one here. I've got the derivative of x to some power is you bring the power out in front, you rewrite the base, and you lower it by 1. Let me do a simple example for this one. Y equals x to the first power. Well, y equals x to the first power, y prime, okay, or the derivative of it would bring the power out front, 1, rewrite the base, lower the exponent by 1. Well, anything to the 0 power is 1, so that means the derivative of this is 1. Why is that the case? Well, think about what this graph really is. It's the line that looks like this, and you're asking yourself, well, what's the slope of this line? The slope of this line is 1. That's why the derivative is equal to 1. So I'm just kind of relating this to a little bit of algebra that you guys already understand. So hopefully you understand the little tricks a little bit better. This one just says that if you have 3 times some function, okay, the derivative of that would be 3, and then the derivative of this, okay, which makes sense. If this is the line, y equals 3x, well, the derivative of that is 3 because you're saying, what's the slope of this line? The slope is 3. So that's the same thing because here's your constant 3, and all we're doing is pulling out front and then taking the derivative of that part, which the derivative of that part is a 1. The next one says that when you have things with adding or subtracting between them, you can take the derivative of each part of those, and we'll see that in examples. This next one says the derivative of sine x is cosine x. You need to memorize this. And then the derivative of cosine x is negative sine x. Alright, the very first example that I want to talk about with you guys, we will actually do in class together. But you should go ahead and look at number 2, see if you can estimate the slope of the tangent line at that point that's there. So pause this, go ahead and look at that example, and make a little notes of it for class discussion. This next part, it just says find the derivative. We're not going to use the definition of derivative to do this anymore. We're going to use the tricks. So what is the derivative of 9? We just talked about the derivative of a constant is equal to 0 because really what this is saying is y equals negative 9. The graph of y equals negative 9 is a horizontal line. And what's the slope of that horizontal line? Well, it's 0. The derivative of x to the 16th. The rule says bring the exponent out front, rewrite the base, and lower this by 1 power. That is the derivative of x to the 16th. The next one. This one, the first thing that you guys will want to do many times before you take the derivative is rewrite it so that it's on one line. So this is what I mean by on one line. 1 over x to the 8th is really x to the negative 8th. So now I'm going to use that power rule, which says bring this out in front, rewrite the base, and lower this by 1. That doesn't make it a negative 7. Lowering it by 1 makes it a negative 9. You can rewrite this. Y prime is equal to negative 8 over x to the 9th. The next one, I'm going to do some rewriting again. This is actually x to the 1/4 power. So the derivative would be equal to, bring this out in front, 1/4 Rewrite the base and lower this by 1. 1/4 minus 1 is negative 3/4. Now I can rewrite this so I don't have any negative exponents. It would be 1/4, and then this would be on the bottom, so it would be the 4th root of x cubed. Let's go through some more examples. This time I've got adding and subtracting between them, but if you remember, in the beginning I talked about how you could take the derivative of each one separately. So we're going to bring this out in front, and we're just going to multiply these together because it's just like multiplying the constants together. So we go 3 times 2 is 6. Write the base, lower it by 1, 2. Minus, bring this out in front, 2, rewrite the base, lower by 1 is a 1. Plus, if you think about it, really the exponent that's here is 1. 1 times 3 is 3. X to the 0 I don't need to write because that's equal to 1. So the derivative is 6x squared minus 2x plus 3. This next one, we have to use the rule of cosine, the derivative of cosine. Well, this is just a constant, so we write the constant out front. The constant is being multiplied by the derivative here. The derivative is negative sine t. The derivative of cosine is negative sine. The last one on this particular slide says, well, what I really want to write here is I have 5/8, this is 2 cubed, and then I have x to the third plus 2 cosine x. I haven't taken the derivative yet, so I wrote g prime. I'm going to come up here to finish this one. So really what I have is g of x is equal to 5/8 x to the negative third plus 2 cosine x. Now I'm ready to take the derivative. So I'll bring this out in front. Negative 3 times 5/8 is negative 15/8. X to the, lower this by 1, that's a negative 4, plus constant 2, derivative of cosine is negative sine x. Final answer, if you want to simplify it, would be negative 15 over 8, x to the 4th, minus 2 sine x. Alright, my next problem here, it gives me a little chart, and I just wanted to show you this based on the problems that I asked you to complete. It talks about the original function, rewriting, differentiate, and simplify. That's the same steps I was doing in all the prior problems, it was just without a chart. So if you like the chart, then you can use it. If you don't care about the chart, then you don't have to use it. It's the same process though. So when I rewrite this, this is really pi over 9x squared. And actually, I'm going to put in an extra step here where I rewrite it again. So it's pi over 9 x to the negative second. Now I'm going to take the derivative of it. So the way I take the derivative is bringing the negative 2 out front. So I have negative 2 pi over 9 x to the, lower this by 1, negative 3. Rewriting it would just make it look like negative 2 pi over 9x cubed. Done. Next problem says find the slope of the graph of the function at the indicated point. So it's asking me to take the derivative. That's what it means, find the slope of the graph. And then they're asking me to plug in 5 for my x value. So I can't take the derivative of this yet. We will be able to learn some more rules later, but we're not ready for those. So in order to take this derivative, what I'm going to need to do is FOIL this out. So I'm doing a lot of rewriting right now. I'm going to have 25 minus 10x plus x squared. I just FOILed first, outer, inner, last to come up with that. And now I have 75 minus 30x plus 3x. Now that it's in polynomial form, what I can do is go ahead and take the derivative. The derivative of a constant is 0. The derivative here would be multiply this by 1, which would give you negative 30. Lower it by 1 gives you x to 0, so it's just negative 30. Plus, we would take 2 times 3, which is 6, and lower our exponent by 1, which would be x to the first. So the derivative is negative 30 plus 6x. But it's asking you to find the derivative at 5, when x is 5. So I'm going to plug in 5. And what I come up with is negative 30 plus 30. So the derivative of 5 is actually equal to 0. The next problem here just says find the derivative. So in order to do that, I need to rewrite this first. So I've got x to the 1/3 plus x to the 1/5. The derivative then is equal to 1/3 x to the, lower this by 1, negative 2/3, plus, bring this out in front, 1/5, lower it by 1, which would be negative 4/5. The only thing else I might do is rewrite this. So I'd have the 5th root of 4 x to the 4th, and here I'd have the cube root of x squared on the bottom. Okay, for my last example for this section, it just says find the derivative. So I'll go ahead and do that again, rewrite it. So I have 2x to the negative 1/3 plus 3 cosine x. Find the derivative, bring this out front, negative 2/3. X, lower it by 1, gives me a negative 4/3. Plus the derivative of cosine x again is negative sign, so I'm going to say negative 3 sine x because we just carry along the constant. The only thing else I may want to do is rewrite this. So I've got negative 2/3, the cube root of x to the 4th, minus 3 sine x.